So it was in the last video that we were looking at histograms. Remember, histogram is a sort of like a bar graph, and we introduced one way to do histograms. We want to show you another way. So the second way is going to involve something called class boundaries. And this is actually the method that's favored by our textbook, using class boundaries. So what are class boundaries? Class boundaries are numbers used to separate classes. So normally when you're having a frequency distribution, you'll have the lower limits and the upper limits for your classes, right? So if you want to find the lower boundaries, it's a new term we want to define, lower boundaries, you subtract 0.5 from your lower limits. Again, you subtract 0.5 from your lower limits to get your lower boundaries. And for your upper boundaries, let me put that in blue. You're going to add 0.5 to your upper limits. Okay? So earlier we had a situation involving rainy days and number of months. So let's write that out again. Oops, I got some scratch here. Don't know what that's about. So we had this frequency distribution a bit earlier. We had the number of rainy days. Per month. So these were our classes, and on the right, we had our frequencies, which were number of months. I remember we had 0 to 4 rainy days in a month, 5 to 9 rainy days in a month, and 10 to 14 rainy days in a month. Those were our classes. And here we're using what are called upper limits and lower limits. Lower limits and upper limits. Oops. 0 to 4, 5 to 9, 10 to 14. Those are limits. Lower limits are 0, 5, and 10. Upper limits are 4, 9, and 14. And we had, 3 months with 0 to 4 rainy days, 7 months with 5 to 9 rainy days, and 2 months with 10 to 14 rainy days. So what I want to do, I want to construct a column. And in this column on the left, we're going to have the class boundaries. So rather than having class limits, we're going to have class boundaries. So I'm going to focus on my lower limits first. I'm going to subtract 0.5 from each one. So if you take 0 minus 0.5, you're going to get negative 0.5. It's going to give you your first lower class boundary, negative 0.5. And the next one, you're going to subtract 0.5. 5 minus 0.5 is 4.5. And for the last one, ooh, I didn't line that up well, did I? Let's line it up a little bit better. 4.5, there we go. Put it on the same line. And the very last one, 10 minus 0.5 is 9.5. Okay, we're going to put a little dash. And then to find the upper class boundaries, we're going to add 0.5 on each of the upper limits. So we're going to have 4.5. Right, we added 0.5 to 4. Now to 9, we're going to add 0.5. We're going to get 9.5. And then on 14, we're going to add 0.5. We're going to get 14.5. So this is our classes represented with boundaries rather than limits. Now, if you wanted to do a histogram using the boundaries, we could. Oops, looks like I got some scratching from earlier. So how could I do that? I could make a vertical axis as before, a horizontal axis as before. On your horizontal axis, you're going to put your class boundaries, which are number of rainy days per month. So these will still be our classes. So I'm going to write classes in parentheses. And I'm going to still make, how many intervals are we going to make? We're going to make 3 intervals, like before. 1, 2, 3. But rather than writing our class limits within each interval, we're going to write the boundaries where the markings are. So I'm going to do minus 0.5. And I'm going to put, oh, what was that about? I don't know. What was the next? 4.5 would be the next one. We're going to put at the next marking. And then after 4.5, we're going to put 9.5. It's the next boundary. And after 9.5, we're going to put 14.5. Okay. And on the vertical axis, you're going to put the frequency, right? Number of months. Let's see if we can squeeze that in. Number of months. I'll put NO period of months. It's the abbreviation for number of months. This is our frequency. I'll just write freq. And we're going to go up to, let's see, how many do we have to go up to? 7, right? 3, 7, and 2 are our numbers. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7. All right, so for the first class, from negative 0.5 to 4.5, we're going to have 3 months. So we're going to draw a bar going up to 3. I like to shade it in. For the second class, 4.5 to 9.5, we're going to go up to 7 months. And then for the last class, 9.5 to 14.5, those are our boundaries. We're going to go just to 2 months. Okay, so there it is. This is our histogram for number of rainy days per month and the number of months. It's quite similar to the initial one we did earlier. The difference is on the initial one, the first one, we use lower class limits and put them within the intervals. The second one, we use the boundaries to demarcate the different intervals. Okay. Now, my take is that anytime you have discrete data, like when you're talking about number of rainy days, they're whole numbers, right? They're discrete. You have 0 rainy days, 1 rainy day, 4 rainy days. I prefer the first method where you use the limits. That's for discrete data. When you have continuous data, it's a good idea to use the boundaries, I think, at least. Okay, so let's do an example where we're looking at temperature. So, let's say we have temperatures for the month of July. So, here I'm going to have a frequency distribution. Consider the frequency distribution so we have 2 columns that are given. Number of days is going to be our frequency, and on the left we're going to have the daily high temperature. This is going to be in Fahrenheit degrees for July. Okay, so we're going to have 85 to 89, 90 to 94, 95 to 99, and 100 to 104. So number of days, 17 days where it's 85 to 89 is the high. 9 days where it's 90 to 94 for the high. 3 days where it's 95 to 99 for the high. 2 days where it's 100 to 104 degrees for the high. Okay, this is for the month of July. So notice that here we have 85 to 89, 90 to 94, 95 to 95, 100 to 104 for our classes. So these are limits here. These are limits, right? You don't see any 0.5s or anything like that. So we're dealing with limits. So let's, instructions, construct a histogram using class boundaries. So here I'm specifically telling you to use class boundaries, not limits. Now in this case, it's an ideal situation to use boundaries because temperature is not discrete, right? Temperature is continuous, meaning you can have decimals. You could have like 89.7 degrees Fahrenheit. And 89.7, well, we'll see where that falls. Does that fall in the first class from 85 to 89, or does that fall in the second class from 90 to 94? Let's determine that. So we want to construct a histogram using class boundaries. So the first thing we have to do, we have to look at the class boundaries. So here on the left, I'm going to make a column that says class boundaries. Squeeze that in there. So remember, to start with the lower boundaries, you subtract 0.5 from your lower limits. You're going to get what? For the first one, 84.5. For the second one, you're going to have 89.5. For the third one, you're going to have 94.5. And for the fifth one, you have 99.5. Those are the lower boundaries. Okay, I want to put a little dash in between. So for the upper boundaries, let's see, we're going to use blue. So you're going to add 0.5, you're going to have 89.5. And for the next one, you add 0.5, 94.5. And for the next one, 99.5. And for the next one, 104.5. So, what if one of the highs was 89.7 degrees? 89.7 degrees. What if you had a day that was 89.7 degrees? Would it fall under that first category, 84.5 to 89.5, or would it fall under 89.5 to 94.5? It would fall under the second class, right? The second class, because 89.7 is above 89.5. Now, what if it landed on 94.5? What if it were exactly 94.5 degrees Fahrenheit? Would it go in the second class or the third class? It would go in the third class. The third class. So you always do once you hit 94.5, it goes up to the next class. It goes up to the next class. So if you had 94.47, it would still be in this second class if you had 94.47. But as soon as you hit 94.5, it's going to go in this third class. Okay. That's when you're dealing with continuous data. It's generally a good idea to use the class boundaries when you're constructing your histogram. So let's do a histogram. So we got to do a horizontal axis. Have to do a vertical axis. And the horizontal axis is going to be daily high temperatures for July. These are your classes here. And we're going to use the class boundaries. How many intervals do we have here? We have 1, 2, 3, 4 classes, right? So we're going to have 4 intervals. We try to space them out evenly with markings. 1, 2, 3, 4. So I'm going to start with the leftmost boundary at 84.5. I'm going to put here at the first marking 84.5. And then the next, crap, what's that doing? The next boundary is what, 89.5? Come on now. And then the next boundary is what, 94.5? Come on, man. Scroll. And the next one's what, 99.5? And the last one's what, 104.5? Those are the boundaries, right? You put them at the interval markings. So there are 17 days, so we got to go up to 17 here. So we're going to have to make this up to 17. So I'm going to count by twos. I'm going to start with 0. This will be 2, 4, 6. So I'm scaling by twos. 8, 10, 12, 14, 16, 18. I decided to scale by twos because I didn't have enough space on this screen. And, oh yeah, we got a label on the left-hand side, right? What are we talking about? Number of days. Number of days. So this is the number of days here. These are our frequencies. Number of days. Frequency. So how many days is the temperature between 84.5 and 89.5? Right here, right? 17 days. So we're going to go down, and we're going to make a bar that goes up to 17 for our first class. All right, and then for our second class, 89.5, 94.5, we got 9 days. Let me see if I can go up to 9 here. Halfway between 8 and 10, right? And then 94 to 99. 94.5 to 99.5 is 3 days. 3 days, come on, dude. And finally, 99.5 to 104.5, that's this last class here, right? It's 2 days. 2 days. There it goes. There you have it. This is a histogram using class boundaries. Yeah. So we got the 0.5s marking the boundaries of the intervals. So again, we usually like to use boundaries when we're dealing with continuous data that's going to possibly involve decimals. So like temperature, for example. All right, so I think that's going to be it for